We can do a few statistical tests once we get the estimation output. So the main statistical test that we need to do once we get the estimation output is the t-test and also the f-test. So basically the t-test is testing the significance of the slope coefficient, and the f-test is testing the overall significance. So for the first test, testing the significance of the slope coefficient, which is the t-test, so for h0 and h1, you have h0 beta I equals to 0, h1 beta I not equals to 0. So meaning if you want to test for beta 2, so meaning that h0 beta 2 equals to 0, h1 beta 2 not equals to 0. So meaning there is no linear relationship between x2 and y, and here there is linear relationship between x2 and y. And you have also one tail test, whether it's a left tail or it's a right tail. So if we write beta 2 equals to 0, beta 2 less than 0, so meaning that we want to claim that there exists negative relationship between x2 and also y. And you can also have the right tail, whereby you can write h0 beta 2 equals to 0, h1 beta 2 larger than 0. So means that we are claiming that there might be exist positive relationship between x2 and also y. So if you look at this null hypothesis and alternative hypothesis, look at the notation used. All these are the population parameter. So we need to write the partial slope coefficient in the original regression model, not from the sample. So from the sample, we are using notation B1, B2, B3, and B4. But in the population model, we use beta 1, beta 2, beta 3, and beta 4. So this is the null and alternative hypothesis, and then you need to get the test statistic. So test statistic for the zero null hypothesis is that T star equals to BI over standard error of BI. So example just now, if you write h null beta 2 equals to 0, h1 beta 2 not equals to 0, and then our t star would be b2 over standard error of b2. So once you get this t star, the test statistic, we need to compare with the critical value, and this follows the t distribution. So if the test statistic is larger than the critical value, we reject h now. And if the test statistic is less than minus critical value, also we reject h now. So this is the rejection region for two-tailed test. And if you look at the subscript here, so meaning we need to find the critical value from the t table alpha divided by 2, because a two-tailed test, and then the degrees of freedom is n minus k minus 1. So using the example, n is 23. And what is k? K is the number of regressors. So you have x1, x2, x3, x4. So you have 4 regressors, and then you have 1 intercept. So meaning that it's going to be 23 minus 5. So 23 minus 5, it will be 18. So meaning that you need to find the critical value for t 0.025 and 18 degrees of freedom. So this is one of the ways using the approach, using the critical value approach, but then you can also use the p-value approach as before that we learned. Is that the p-value that we get from the output, if it is less than the significance level alpha, then the decision will be to reject h now. So the p-value here under the column significance here, this is for the zero null hypothesis two-tailed test. So meaning that from the estimation output, this one is referring to the hypothesis h null beta I equals to 0, h1 beta I not equals to 0 is a two-tailed test. So if you want to test beta 1 equals to 0 or beta 1 not equals to 0, then you can straight away look at the p-value. This is not less than any of the alpha levels, so this is bigger than 0.10, so we do not reject H null. If you look at other p-values, so this one is less than alpha 0.01, this is less than alpha 0.01, but this is not less than any alpha level. So meaning that we know we will reject the zero null hypothesis when we want to test for beta 2 equals to 0 and also beta 3 equals to 0. So here the decision will be do not reject H null. Here the decision reject H null, and also do not reject H null. So the p-value shown in the estimation output is for the two-tailed test. So if we want to do the one-tailed test, example here at 1%, 0.01 level of significance, determine whether the per capita consumption of chickens negatively related with its real retail price. So here we have the claim that it is a negative related. So we can write H null beta 2 equals to 0, H1 beta 2 less than 0. So it's a one-tailed test. So still you can use two approach. One is the using the critical value approach. Another one is using the p-value approach. So here you can get the critical value minus t alpha level, so you don't have to divide by 2, just straight away use the 0.01, and then degrees of freedom is going to be 23 minus 4 minus 1, so it's going to be 18, and then you get critical value minus 2.552. It is at the left side, so the value of t will be negative values, and then we reject because the t star here minus 3.75 3.753 falls in the rejection region, which is smaller than minus 2.552. So the decision is to reject H null. So for the P approach, since we use one tail test, then we need to get the p-value, and the p-value here is going to be 0.005, and this p-value is less than alpha level 0.01, so it means that we reject H null and say that either of this approach tells us that there is evidence that the per capita consumption of chickens negatively related to its real retail price. Here is a two-tailed test, okay? 5% level of significance. Determine whether the per capita consumption of chickens significantly related with real retail price of beef. So here it does not state the sign of the beta. Means that it's just they want to claim whether is there any relationship between the real retail price of beef and also the consumption of chicken. So it's a two-tailed test. Beta 4 equals to 0, beta 4 not equals to 0. So for a first approach, you can use the critical value, two-tailed test, alpha divided by 2, 5% divided by 2, 0.025. Degrees of freedom 18 is going to be plus minus 2.101. So since the test at stake 1.363 is less than 2.101, it falls in the acceptance region, so we fail to reject H null. And if we use the p-value approach, we can use the p-value given in the estimation output. Because it is a two-tailed test, then this p-value 0.119 is larger than alpha 0.05. So meaning that we cannot or unable to reject H null. So meaning that there is no evidence that per capita consumption of chicken is significantly related to the real retail price of beef. Testing the validity or overall significance of the model. So here the null hypothesis would be beta 1 equals to beta 2 equals to until beta k equals to 0. So you are writing all the population parameter except the intercept. So we are just picking up the partial slope coefficient. So we have beta 1 not beta naught. Okay, so it's just starting from beta 1 until beta k equals to 0. So means that this H now, the overall regression model is not significant, and H1 at least one of the betas is not equals to 0. So the test statistic would be F test. So our calculated F is the SSR, the sum of squares regression, divided by K over sum of squares error divided by N minus K minus 1. So this is the mean square of regression, and this is the mean square of error. And then we reject H now if this calculated F is larger than the critical value from the F table, or the p-value is less than the significance level. So for the F table, as usual, you need to have N1 and N2. So you need to have 2 degrees of freedom. So the first degrees of freedom will be K, the number of regressor. The second degrees of freedom will be N minus K minus 1. So if you see from the formula, this one will be the degrees of freedom for the numerator. This one will be the degrees of freedom for the denominator. The values for the F, calculated F or F test, is given in the Anova table. So in Anova table, it will tell us what is SSR, which is the sum of squares regression, SSE, and also the degrees of freedom, and this is the mean square, meaning that SSR divided by K, you get MSR, SSE divided by N minus K minus 1, and then you get MSE, and then divided MSR over MSE, you will get F star. So if the overall regression model significant at alpha equals to 0.025. So here it wants us to use the overall significant test, meaning the F test. So first state the H now and H1. H now will be beta 1 equals to beta 2 equals to beta 3 equals to beta 4 equals to 0. And H1, at least one of the betas is not equals to 0. And then the critical value is going to be F alpha level 0.025, 4, and 18. So here 4 because the K is the number of regressors or independent variables is 4, and 18 is N minus K minus 1. So basically this is N minus the number of population parameters including the intercept. So 23 minus 5 is 18. So you have the critical value from the F table is 3.61. So this is the first approach. Once you get the critical value, you compare with the calculated F. So the calculated F, this is the sum of squares. Okay, so divide mean squares over mean squares of regression over mean square of residuals, then you get 73.871. So this one compare with the critical value, it is larger. So we know the decision is to reject H now. So if you are using the p-value approach, simply use the p-value that you get next to the F test or F stats here. So it is 0. A very low value, 0.000, which is less than 0.025. So therefore we reject H now. So meaning that the overall regression equation is significant.